Welcome to our foundation channel from class 9th mathematics, the chapter number 9. It is a triangles. So congruency in triangles concept I'll explain in this chapter one by one. First let us see some basic introduction. Then relation between sides and angles of the triangles. So type of the triangles based on the sides and based on angles, right? And some important terms in this understanding the concept of triangles. Let us see some important terms like median, altitude, centroid, orthocenter. Those terms I'll explain. Next, conditions for congruency of triangles. How we can say the triangles are congruent or congruency of triangles concept, various type of conditions. So I'll explain here and see the problems based on this congruency in triangles. Right. So when you see the word triangle, a plane figure bounded by three straight lines. Already we know three straight lines. A closed figure again. A plane figure bounded by three straight line segments is called a triangle. So let's take A, B, C. Okay, here is the point A. These two line segments are joining at one corner. No, there is the vertex A, and it is the B and C. So here is vertices. So vertices are A, B, C. A, B, C are the vertices and sides. So not of confusing to write that the sides and vertices. Actually, vertices is the single letter, capital letters, corner points, and sides to denote A, B, right? A to B, the distance from A to B is this. A, B is the side. Just to write two capital letters side by side. A, B, and B, C is the side. C, A. So some of you in books you can keep the line segment A, B, B, C, C, A, or without making this also you can make this. Just only A, B, B, C, A, C. To denote the side, we write the two letters side by, and vertices is the corner vertex, corner points, A, B, C. Right, here there are three vertices and three sides for the triangle. Again, the angle in this, three angles. To denote this is angle A, or we can write BAC, angle BAC. Start from the B to A and C. So angle BAC is this. Same way, this is angle B or angle ABC. Now this is angle C or ACB. This we can denote the angles. B we can make ABC is angle. C is here. Angle C or angle ACB or BCA. Both are same. BCA or ACB. This is the basic things. Let us see the relation between sides and angles of the triangle and some properties also show here. Relation between sides and angles of the triangles. So in this concept, so four properties or four basic important things I'll explain here. First one, if all the sides of the triangle are of different lengths, its angles are also different measures in such a way that the greater side has the greater opposite to it. So let me take the triangle. Four properties. This is the two, and next to two I'll show you. For example, so ABC is a triangle. This property says all the sides of the triangle are different length. So AB, BC, AC are different length. Its angles are also different measures. So the three sides are different and angles also different. That means the greater side has the greater angle opposite to it. In case if AC is greater than AB, so length of AC, in case it is greater than AB, then if one side is greater than one of the side, then AC opposite angle is B. So angle B is also greater. For AB opposite is C. So is angle C. If AC is greater than AB, then AC opposite angle is also greater than, which is a small side. There's a difference here. Greater side has greater angle opposite to it. Clear? And next one. Conversely, same one, just conversely you can write. If all the angles of triangle have different measures, its sides are also different length in such a way that Greater angle has the greater side opposite it. If the angle is greater. So let us take the triangle. And this is a triangle ABC. Sum of the three angles is 180 degrees. Let us say ABC. If A is 100 degrees and C is 50, 150, no, it must be 30. Okay, so this is the approximately take. Angle A is greater than angle B. Angle A is greater than angle B. So angle A opposite side is BC. So BC is greater than, next B opposite is AC. So if any angle is greater than other angle, then that angle opposite side is also greater than opposite. Same way, small. From this, we know angle C is less than angle B, right? Angle C is less than B. Then angle C opposite is AB. So AB is also less than and AC. Right? This is the conversely we can say this. If the side is greater, greater angle opposite it. If the angle is greater, then opposite side is also greater. Right? Same way, vice versa. It's smaller, then small we can take. Right? And next two points here, you can see here. If any two sides of triangle are equal, the angles opposite to them are also equal. Conversely, if the two angles of the triangle are equal, the sides opposite them are also equal. Same method. If different measurements, different sides, different angles, right? If the same side, length of the two sides are equal. Now ABC is a triangle. Let's say AB is exactly equals to AC, right? If two sides are equal, their opposite angles also equal. So AC side opposite angle is B. AB side opposite angle is C. So if AB is equals to AC, then AB opposite. So angle C is also equals to angle B. Right. So any two sides are equal. Those two opposite angles, those two sides opposite angles are also equal. Same way if you go for three sides. If all the sides of the triangle are equal, all the sides of the triangle are equal, that is called equilateral triangle. This is a triangle. Three sides are equal of A, B, C. Same measurement. If AB is 5 centimeters, every other two sides also 5. Okay, AB is equals to AC is equals to BC. If AB is equals to BC is equals to CA. If three sides are equal, then their opposite angles are also equal. That is angle A is equals to angle B is equals to angle C. Now this is a equilateral triangle. Sum of the angles in a triangle is 180 degrees. So 180 divided by 3, 60. So every angle must be equal to 60 degrees because it's a equilateral triangle. Already you studied in previous class the type of triangles. If two sides are equal, three sides are equal, no side is equal. So equilateral triangle, isosceles triangle and scalene triangle you studied, right? So based on those we can use this formula. Property is this, right? If three sides are equal and their opposite angles also same. Right? These are the important properties you'll apply in the problems, and let us see some important terms in this. Some important terms in this triangles, in congruency in triangles, let us know some important terms in this. So median and altitude I'll explain. First, when you see the word median. So median of a triangle corresponding to any side is the line joining the midpoint of that side with the opposite vertex. Let us take the triangle. Now in this triangle, three sides ABC. Median of a triangle, which is line joining the midpoint of that side with the opposite vertex. So from vertex A, if we join the line to the midpoint of opposite side. So BC midpoint. Let's take BC midpoint is D. So these two are equal. D is the midpoint of BC from midpoint of one side to the opposite vertex. If you join the line, this is called the median. So now AD is the median in this, right? Again, we can make three medians total. So from vertex A, we have done one, right? Let's take the same triangle. In this first example, AD is the median. Take say ABC. ABC. So total 3 medians we can make. And from the B to midpoint of opposite side, right? Again from the C, midpoint of opposite side. Here is these two are equal. These two are same. So let's keep some letters name E and F. Let me this is E and F. So in first diagram, AD is a median opposite to the side BC. Next in this diagram, BE is the median opposite to AC, and in the CF is the median opposite to AB. Right. So by taking these three in one diagram, so the triangle has the three medians and all the three medians are always concurrent. That is, they intersect each other at one point only. Let me take three medians to construct in single diagram. So one triangle. Instead of taking separately, just in one triangle itself, three medians I'll take. Now ABC. As per the rule, from vertex A, you should join the midpoint of opposite side. Right? And from the B, you should join the midpoint of opposite side. From C, if you join the midpoint of opposite side. So this is D, E and F. Right? So these 3 points will join at one point itself. So they'll coincide in only one point. The triangle has 3 medians, no? And all the 3 medians are always concurrent. Concurrent means they intersect each other at one point only. So this intersecting point we can call it as a centroid. So we can denote with G. This is centroid. So point of intersection of the medians is called centroid. Point of intersection of the medians is called centroid. So here is BC is equals to BD is equals to DC, and AE is equals to EC, and AF is equals to this BF, because vertex to midpoint of opposite side is called median, and the point of intersection of the medians is called centroid, that we can denote with G. Here we have the rule AG is to GD. So A to centroid and centroid to the opposite is 2:1 ratio. Same way, vertex to centroid always. Vertex is B. So BG to GE is 2:1 ratio. So if it is two parts, this is one part. Same way, CG is to GF is 2:1 ratio. So vertex to centroid. So centroid of triangle divide each median in the ratio 2:1. So from vertex to centroid and centroid to the midpoint of opposite side. This ratio is 2:1. Right? This is about the median. So joining the vertex to midpoint of opposite side. Next one, we have altitude. So altitude of a triangle corresponding to any side is the length of the perpendicular drawn from opposite vertex to the side. Perpendicular drawn. Let's take first one. This is a triangle ABC. From vertex, perpendicular drawn from the opposite vertex to the side. From vertex A, if you draw exactly perpendicular to this base, BC. Perpendicular, it must be 90 degrees. AD. So AD is the altitude now. So altitude of a triangle corresponding to any side is the length of the perpendicular drawn from the vertex, from the opposite vertex to that side. So AD is the altitude. If you join the midpoint, that is median. If you draw perpendicular to the base, that is altitude. Same way we can make 3 altitudes here. Right? Let me take the diagram. From every vertex, perpendicular drawn we can make 3 triangles. Same, say ABC. A we have drawn perpendicular. Now from the B we can draw exactly perpendicular to this opposite side. Say E, and from C we can draw perpendicular line. CF. So CF is perpendicular to AB and BE is perpendicular to AC. AD is perpendicular to BC. That's why AD is the altitude corresponding to the side BC, and BE is altitude corresponding to the side AC. CF is altitude corresponding to the side AB. Right. Now these three altitudes also intersect at one point, that is called orthocenter. Let me show you diagram. Let us take in one triangle, draw three altitudes. Say A, B, C. So as per the rule, from vertex A, we should draw a perpendicular line to the opposite side, 90 degrees. And from C, you can draw a perpendicular line. From B also, you can draw a perpendicular line. So here is point of intersection of altitudes of a triangle is called orthocenter. So you can denote with O. We denote with capital O. This is orthocenter. The point of intersection of altitudes of a triangle is called orthocenter. Right. So here is perpendicular AD is perpendicular to BC. Same way as B is perpendicular to AC and CF is perpendicular to AB altogether. So that point of intersection of altitudes of a triangle is called orthocenter. So we have the median and altitude. Median intersection point, no, that's a centroid, and altitude intersection point is orthocenter. Conditions for congruency of triangles. So what are the conditions you have to apply to say the triangles are congruent? So I'll show 5 conditions with the diagrams in this one by one. First one, if 3 sides of one triangle are equal to 3 sides of other triangle, each to each, the triangles are congruent, that is triple S property, SSS, axiom or triple S property. 3 sides are exactly equals to another 3 sides of another triangle here. 3 sides of one triangle are equal to 3 sides of other triangle. AB exactly equals to DE, right? And this BC is equals to EF and AC is equals to DF. So 3 sides. This is also one of the side and side and side. So triple S, by triple S property or triple S axiom, triangle ABC is congruent to triangle DEF. That means exactly coincide. So ABC triangle will coincide on this DEF. So congruent. One property is triple S, because to solve the problems we need to apply those properties in these questions. Now one more, second one, SAS property. Side, angle, side. That means one side, one angle and one side should be matched with each other. So see the statement. If two sides and one included angle, because letter A is inside, middle of this double S, SAS, right? Two sides and one included angle one triangle are equal to two sides and included angle of the other triangle. Then the triangles are congruent. So AB is exactly equals to DE. Now if it is 4 centimeters, it's also exactly 4. So same measurement. AB is equals to DE and BC is equals to EF. Same time include angle. Angle B is equal to angle E. So by SAS property, ABC triangle and DEF triangle are congruent. So this is a symbol for congruency. Congruent. The abbreviation you can use as SAS property. Side, angle and side. Next one, angle, side, angle. Here is the side is in middle. So two angles and side is at the center. So if two angles and included side of one triangle are equal to same two angles and included side of other triangle, the triangles are congruent, then the rule is ASA. So here is angle, side, angle, right? So angle A and angle D are equal, and angle B, angle E is same, and included side is this. These two angles are included in this. With this side only, these two angles. One is one corner and the other corner. So AB is equals to DE. So angle, side, angle. So by ASA property, triangle ABC and DF are congruent. Next one more. Total 5 we have. Here is a third and fourth are similar, but angle, angle and side. AS if two angles and one side of one triangle, not included here, right? See this, two angles. One side of the triangle are equal to two angles of the corresponding sides of the other triangle. Then triangles are congruent. So angle A is D equal to D and B is equal to C. At the same time, angle C also is exactly equals to angle F, because sum of the three angles in a triangle is 180 degrees. Sum of the three angles. If two are equal matching, then third also must be matched. There's nothing but ASA or AAAS. It will be same rule you can apply, but you can write the property like this, AAS axiom. Because angle and side. Obviously this is also same by property. So it's nothing but again angle side angle. So third and fourth are same, but if you measure separately like angle and side, you can use the word by AAS axiom. These two triangles are congruent. And fifth rule. This is right angle hypotenuse side. See here. Two right angle triangles are congruent if hypotenuse and one side of the one triangle are equal to hypotenuse and corresponding sides of other triangle. So anyway, two right angles, one angle is 90 degrees, fixed it is, and hypotenuse and one side should be equal to one another. So here is angle B is equals to angle E, 90 degrees, and AB is equals to DE and AC is equals to DF. Compulsory hypotenuse must be equal. AC is equals to DF, and from other two sides one should be equal. So AC is equal to DF and AB is equal to DE by RHS. So generally you can use right angle, hypotenuse and side. R is right angle, hypotenuse and side. So right angle is there, hypotenuse is equal, and one of the side. These two are equal, right? AB is equals to DE. So this is RHS property. So these properties or these congruency rules, these 5 rules, we are going to apply to solve the problems in congruency of triangles. Problems based on congruency in triangles. So we discussed already the conditions to prove incongruence in triangles. Those conditions you will apply to solve the problems. I show two different and important sums. Based on that, you can do the other calculations or other sums also. Right? So in this problem, in the given figure, ABCD and ABEF are parallelograms. ABCD and ABEF. These two are parallelograms. So opposite sides are equal. That means AB exactly equals to CD. Right? Again AB is equals to FE. Opposite sides are equal in parallelogram. O is the midpoint of BC. Show that DC is equal to CF is equal to FE. DC, CF and FE are to prove same. As per the parallelogram property, AB is equals to this DC is equals to FE. But if I prove DC is equal to CF also, then we can say all three are equal. So this AB and CF are which two triangles you observe? These two triangles you take. So this is one of the triangle and these two. In case if I prove these two triangles are congruent, so by corresponding parts of congruent triangle, CPCT, then AB is equal to CF will write. First prove triangle ABO and CFO are congruent. So AB is equal to CF will get. Then again already we know AB is equal to DC, AB is equal to FE. So three are equal. Right. So first let us take in triangle ABO and triangle FCO. So these two triangles you have to prove congruent. Using the congruency rules, any one of the property can apply to prove these two triangles are congruent. First, OB, because they mentioned O is the midpoint of BC. You should take the given data. O is the midpoint of BC. So OB is equals to OC. Okay, so this is the given. And we already got one side is the matching. Two triangles. It's common. Next, angle AOB. These two angles are same because vertically opposite angles. So these two angles are same. Angle AOB and angle COF or FOC. So angle AOB, AOB and this FOC. are equal because vertically opposite angle. You can write the reason also. Vertically opposite angles are equal. Next. So we got only one side and one angle as of now. Then alternate angles. Already we know these are two lines are parallel, right? AB is parallel to DC. These two lines are parallel, and if it is transversal, you can see this angle B and angle C. Use the rule here. If two lines are parallel, the line is transversal, alternate angles are equal. Okay. These two lines are parallel and transversal, alternate angles. Here is AB and DC are parallel lines, like BC is the transversal. Observe. AB is parallel to DC, BC is the transversal. So angle B and angle C. Here B is nothing but angle ABO, or else OBA. Same. So OBA is exactly equals to OCF. OCF. These two angles are the same. This is alternate angles. Alternate angles are equal. Side, angle and angle. So angle, side, angle ASA. Therefore triangle ABO is congruent to triangle FCO. So reason is by angle side angle property. Right? So whenever two triangles are congruent, then corresponding sides are equal. Therefore AB is equals to CF. This is by CPCT. Corresponding parts of congruent triangle. Whenever two triangles are congruent, corresponding parts are same. So AB is equal to CF and AO is equals to OF. So BO is equal to OC. All corresponding angles and corresponding parts are same. So AB is equal to CF. So already we know that AB is equals to DC. This is one. Again AB is equals to DC. Opposite sides of the parallelogram. And AB is equals to FE also. These two conditions opposite angles, opposite sides of the parallelogram. So therefore we can write DC is equals to CF is equals to FE, right? So main thing is these two triangles. Which two triangles you are to congruent? Those two triangles you check which property can apply and just use the rule, right? See one more problem in this question. Here is the thing. See this question here, two ones. In the given figure, ABCD is a square. Okay, ABCD is a square, so all the sides are equal. M is the midpoint of AB and BQ. M is the midpoint of AB and BQ. It's a midpoint, right? So AM is equals to MB, and these two sides are equal. M is the midpoint of PQ. So PM is equal to MQ, AM is equal to MB as of now. CB produced meets PQ at a point Q fixed end. Prove that PA is equals to BQ. Here is the PA. This is equals to BQ. Prove these two triangles are congruent. Which two sides you have to prove equal? Those two sides combination triangle you observe. To prove PA is equal to BQ, first these two triangles you prove congruent. So in triangle PAM and triangle QMB. Okay. So these two triangles, already M is the midpoint of AB and M is the midpoint of PQ. So all these sides are equal, we're matching. Then angle A. Each angle is 90 degrees. Again, one more rule. So if you observe, angle A is 90 degrees, angle B is also 90. So this straight line, no, this also must be 90. Yes. So we have the three rules are here. So angle A is equals to angle ABC. If angle ABC means exactly equals to MBQ also. Angle of straight line is 180. That is equals to MBQ also we can write. So each angle is 90 degrees. Each is 90 degrees in square. Yes, this is the angle rule we got. Again we have this two sides. M is the midpoint of AB. That means AM is equals to MB and M is the midpoint of PQ is mentioned, right? So PA, that means again PM is equals to MQ. These two rules is given in the question. This is the midpoint. So we got side, angle and side. Therefore triangle PAM is congruent to triangle QMB. This is side angle side. Side angle side property can use. So by CPCT we can say this PA is equals to BQ. Corresponding parts of congruent triangle, right? So this is one. Similarly, this is in the second part. Observe this. CP, okay, CP is this, is equals to AB plus PA. CP is equals to this AB plus PA. PA is this. So we should prove the sum of this. So already we proved here PAM, triangle PAM is already congruent to triangle QBM, we proved, right? From the proving we can take this. From this already we got PM is equals to QM. PM is equal to QM. Already is given. PQ is a perpendicular to CM. M is the midpoint of AB. PM is equals to QM. That is by CPCT. Okay, from this you can take by CPCT. Here is one part only is given, right? M is the midpoint of AB and PQ is a perpendicular to CM. PQ is perpendicular to CM. So this is 90 degrees. Okay, even you can use alternate angles also, this rule. Previous one, you can use this vertically opposite angles. PM. Instead of take this line, you just take, okay, this first one is given and PMA angle exactly equals to BMQ. Okay, so angle side angle, okay, two angles in one side. So angle side angle we can use. Angle side angle. Okay, don't take this one because you are proving for second one I am taking. PM is equal to QM by CPCT. This part. PM is equals to MQ or QM. We got right. Next, every angle is 90 degrees. CMP angle CMQ, that is equal to 90 degrees, and CM is equals to CM. This is a common side. CM is a common side. So I am taking these two triangles. So therefore triangle PCM is congruent to triangle QCM. PCM. These two triangles. Take the color. These two triangles you prove congruent. Therefore CP is equals to CQ by CPCT. CP is equals to CQ will take. CP is equals to CQ, we can write CB plus BQ. Instead of CB, just you can take this AB. Because all sides are equal. Plus instead of BQ, take PA. BQ is nothing but PA, no? First one you got proof from the first it is. So CP is equals to AB plus PA we can take. Right. So any triangle is given. First from the given data only you can make this points, and from that what you have to prove by CPCT can use this. So you can expect the similar questions in most of the congruent triangles. Just apply the rules and file. You can see the links in description below for the material and some other notes. You can subscribe to our channel.